So the integral of x e to the x, okay, most people just derive it from integration by parts, and get e to the x minus 1 plus c, okay? So if you got to this point, 10 points, okay? Okay, now I'm going to do is divide by x e to the x to get y out of this thing, right? Well, I think you do different ways. I found the initial condition now. Okay, so I left it like this, doesn't matter when you did it. And now I plug in the initial condition. What was the initial condition on this thing? Y log 2 is 1. Looks like a weird point, but I do that to make the arithmetic easier, okay? So when x equals the natural log of 2, y is equal to 1. Okay, so just plug that in to find your c. Okay. So on the left, we have x e to the x y, okay? Log 2 log 2, I guess, right? Let me just, yes, I get x, which is log 2 times e to log 2. Yeah, 2 log 2. And I had at least 2 people come up to me during the exam and ask me what e to the log 2 was. Okay? So if you left in terms of e to the log 2, maybe I took off a point or something, but, you know, what can I say? E to the log 2, okay? Okay, so you get 2 log 2 equals 2, right? Because we get e to the log 2 again. Then we get log of 2 take away 1 plus c. And the arithmetic, all the log stuff goes out. You'll find out that c should equal plus 2. Okay? So let's plug that in. So we have x e to the x. Oh, so let me just tell you again the point is, let's go over the points again. So 5 for the integrating factor, right? Okay, that's over there. 10 if you got to this point for the general solution, and 5 if you got the arbitrary constant, right? Okay? So, but you really should bring it in terms of y. It says let's find the general solution. It's explicit, so I didn't take off. If you left it like this and plugged in the c, then it's fine. But we really should solve for y, right? And then you'll get x e to the xy is equal to, just plug into the c, e to the x minus 1 plus 2, and finally we can solve for y by dividing through. That becomes e to the x minus 1 plus 2 divided by x e to the x. Okay? Any questions on that? Okay. So that's problem number 3. Okay, it brings us to problem number 4, and again, just think of all the things we covered, right? So we did already autonomous equation, reciprocal, first order linear. What else was left? What we did was exact, right? This is problem number 4. What I found interesting is that I would think that of all these, probably 4 and 5 are the most difficult, and most people did. People who kind of some people didn't even do the linear one, got 0 credit, and they got 4 and 5 correct. I mean, I don't know. Maybe because it was the last thing that we did. I can't really explain this. Okay. Okay, you got the thing in front of you, so I'm not going to write it out, right? You got some s dx, some dy is equal to 0. And then you see below that, I give you an integral, and you should say, I don't give that to throw you off. Obviously, if you didn't make a mistake, somewhere along the line, in solving problem number 4, you will need the integral of the log of y. And I give it to you. I don't want you to figure that one out. Okay, so the first part is you should prove that it's exact. Okay, 5 points for doing that. Okay, so we have, I'll just write down y squared cosine x minus 3x squared y minus 2x, that's the differential x coefficient. Okay, y squared cos x minus 3x squared y minus 2x dx plus 2y sine x minus x cubed plus log y. Sorry, dy is equal to 0. Okay, and I'm don't care what you call these, MN, like the book does, okay? We want to basic, and again, I did not take off, but you'll notice that some people like corrected. Some people would, you know, they write dm dx like this, and I was very emphatic that, you know, it's a partial derivative, and it's going to make a difference later on. And it's a bad habit to get into where you don't distinguish in your notation between a partial derivative and a total derivative, okay? But you didn't lose credit for it if I saw that, you know, the answer was pretty much standard. Okay, so we test for exactness. You take the partial of m with respect to y, okay? What are you going to get? You're going to get 2y cosine of x, and differentiates this respect to y minus 3x squared. Okay. And then the partial of n with respect to x. Some people didn't, and this, you know, you lost credit for. Some people made a mistake and say, oh, I know it's going to probably be, this is probably a question that's exact. So they made a mistake, they differentiated this thing wrong, they differentiated this wrong, they made the things equal. You know, I would rather that you had made a mistake and then recognized it than, you know if you did it, right? Okay, you know, these are just straightforward differentiations. Partial of n with respect to x is equal to 2y cosine x, right? And differentiate that respect to x minus 3x squared. Okay, so it's exact, right? Because these guys are equal, and that was 5 points, just for doing those differentiations and showing that it was exact. Okay, and now we've got to integrate this thing. And again, some people did, and it just throws me off. Okay, I don't care what notation you use. Okay, I think in class I said, you know, this is exact, and we have, that's the total differential of u, and I wrote down du dx equals this du dy. The book uses df dx, that's fine. But what threw me off, and you know, I've seen it so many times, people would write f sub x equals, to me that means partial f partial x, and I was expecting to see this. Instead of seeing this, it was the integral that you gave. Okay, I mean I started marking it, I was taking off credit until I realized what went on. Okay, but be careful. Okay, if you're going to write f sub x, that means this guy. If you're going to write the integral of this thing, then that's f. Okay. And some people even wrote, they wrote down df dx equals this thing, then they put an arbitrary function in there. The arbitrary function doesn't come until you until you integrate, right? Again, I didn't take off credit, but it showed to me that you really didn't understand, you know, the whole methodology. Okay. You only get an arbitrary function just like when you integrate in general. If I do the integral of x cubed dx, it's x to the 4th over 4 plus c, right? You don't get a constant in there or an arbitrary function here until you integrate. Okay, so I'm just going to stick with my notation, okay? So since this is exact, there exists a function. Let me do the f because most people did that, okay? So there exists a function f of xy whose total differential is equal to that. And we know that means that partial f partial x has to be this guy, which is y squared cosine x minus 3x squared y minus 2x, right? And similarly, partial of f with respect to y is your dy coefficient, which is 2y sine x minus x cubed plus the log of y. Okay, and which one? Some people integrate this, some people integrate that. Most people integrate the first one. So let me just do it that way. Okay. Okay, so now you see it's important. Oh, let me tell you something else. And I said this happens every semester. And you remember I spoke about this at length in class. Some people did it, okay? Some people go through this. And this is what happens when you don't distinguish between partial and total derivatives. They sort of dx over here. So they say, oh, I'm just going to integrate everything like partial with respect to x. So they wrote down y squared sine x minus x cubed y minus x squared. And then here, oh, I see a dy. I'll make that y squared sine x minus x cubed y plus the integral of log y. Like I said in class, if you could do that, then the class would be over after the second week, okay? Y is a function of x. See, when you write down partial f partial x, that's completely different. you're saying basically that when you want to find f, you're integrating, and because it's a partial derivative, you can keep y fixed. But when you have it over here, where y is a function of x, you can't do that, okay? And at least 2 people did that, even after I went over it so many times. Okay, so we'll do it again, right? Okay, so let's take this partial f, partial x, and integrate that one. Okay. I'm going to integrate this one. Okay. So now we have f of xy equals, now remember, I'm integrating partial with respect to x. So now we got y squared sine x minus x cubed y minus x squared plus some arbitrary function of y. Right? Where g of y is arbitrary function of y. Notice where the arbitrary function comes in. It's over here after I integrate. Some people wrote down this and they put an arbitrary function of y over it. It doesn't make any sense. Right? This thing comes directly from the differential equation. Okay. And now, of course, you have to get your g of y, and the way we do that is we take the partial with respect to y and we compare with that. And again, remember I told you that a good check on your algebra is that when you get to a point and you have g primed of y, all the stuff in x has to go out. And what happened? Some people made a mistake. They had g primed of y, they had x in there, and then they did that old trick again of theirs where they just completely ignored it and integrated partially. Okay? G is only a function of y, so they can be, when you do dg dy, there can be no x dependence in there. Okay, so let's take the partial of f with respect to y now. Okay, and compare. Partial of f with respect to y, that's going to be a 2y sine x, right? Partial y, right? Differential sine x minus x cubed, right? That's nothing plus g prime of y. But we know partial f, partial y. It's right down there. So that equals 2y times the sine of x minus x cubed plus the natural log of y. And notice how everything in x does cancel out. So we're left with g primed of y equals the natural log of y. So what's g of y? It's just the integral of log y dy, which I give you. What did I give you for that? Y log y minus 1. Okay. Let's review the credit on this one. Like I said, 5 if you showed that it was exact. 10 if you got, I'm sorry, no. 5 for exact, and then 10 for getting f of xy. If you got up to, I'm going to show you exactly where it was. 5 we got f of xy. Yeah. So if you got to here, basically 10 points, okay? And then when you got to this point, 5. Okay, and that gives you the full 20 for this. Okay, so let's just finish this up. We find, therefore, that we got everything that we need, right? So f of xy is equal to y squared sine of x minus x cubed y minus x squared plus g of y, which is y paren log y minus 1. And again, some people, I can understand why when you're so get involved in this thing, getting the effort like that, you forget that you have to write down the solution. So you lost, a point or two if you just stopped here and you didn't say the solution is f equals constant. So solution is y squared sine of x minus x cubed y minus x squared plus y paren log y minus 1 is equal to c. Yeah, okay? Well, you could, if you did f of xy equals this, and the next line was solution is f of xy equals c, that was fine. Okay? But remember, the whole idea is that you're going to solve this differential equation. So, like I said, this is the really bulk of the work. I'm not going to take over too much credit. You got to say solution is this, and you just left it over here. One point or two, depending on how bad it was. Okay, so that's problem number 4. And again, remember, I think for those who were here, the exam was on a Monday, on a Wednesday, and I said, I'll probably give you one like this, right? Remember, I don't have one in class. I said, I'm not gonna, which comes on this one. Remember I said, don't memorize that crazy formula of the mx minus ny over n, okay? I assume those people weren't listening or never came to class. Some people did it, and actually it doesn't even work. Because you recall that was a special condition, right? I can't even remember anymore. So it was like mx minus ny over n is a function only of y. This is an integrating factor. If this over m, okay? And some people, I guess they memorized it, but they never even checked that it was a function of x or just of y. And then when they got to the integration, again, they played that trick. Oh yeah, integral of x squared y dy is x squared y squared over 2, okay? So, no credit on that. I mean, it shows me that you don't even understand, the basic, underpinnings of the whole course, okay? Okay, so let's do problem number 5, okay? Pretty much the same as problem number 4, a little more work, because you have one more step to show that the equation is not exact. Now again, don't come to me and say, oh yeah, look, I showed that it wasn't exact because partial m partial y was not equal to n dx. Some people differentiated incorrectly. Okay? And the chances are if you differentiate incorrectly, you're going to say it's not exact. And you even know the answer to part A, right? Show that this equation is not exact. So therefore, if you made mistakes on your partial derivatives, you did lose some credit, okay? Because, okay, let's go over here. This will be the last one. I'll just write it out. This is the sine of y divided by y minus 2 e to the minus x sine of x. That's the differential of x coefficient. And then we got cosine of y plus 2 e to the minus x cos x. The whole thing divided by y, dy equals 0.